Hey guys, Mr. Mackey here. Now last week we had Shapes Week, and this week, welcome to Shapes Week. This is going to be a 2-week long pro lesson because I thought there's a lot to cover. There's no point me coming back to something. Might as well just do it all in one go because why not? Now, last week we focused on finding the areas and perimeters of rectangles, squares, triangles, compound shapes. Now this week we're going to be for the first couple of days, we're going to be finding how to get the areas of more complicated shapes. So let's get started. So I have here a shape called a parallelogram. Try saying that 5 times fast. Parallelogram, 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 parallelogram. Oh, blimey, I couldn't even do it. Now, I want to find out what the area of this parallelogram is. I'm going to be saying that a lot today, so let's see how many times I get it wrong. How do we find it? Well, here's a trick that I use to help you guys identify the simplest way to find an area. What I first do is I make a dotted line here to turn this part of the parallelogram into a triangle. Then what I do is I move that triangle to the other side of my parallelogram. That's still 6 there, because it's still the height. That's still 8, because that's the base. The base has just been attached to that side instead. What is the area now? What shape have I just made? I've made a rectangle. So all I have to do is, as long as you know the height, which is 6, and the base, which is 8, you multiply them together, get 48 meters squared. So the area to finding a parallelogram is exactly the same for finding an area of a rectangle. It's just the base times the height. We can also do the same for this shape. Now this shape is known as a rhombus, but easier to say than a parallelogram, isn't it? Now, to find the area of the rhombus, we have our base, which is 7, and we have our height, which is 7. We move that line across, so the triangle's formed there, which still has a height of 7, and we just do 7 times 7, which becomes 49 meters squared. Why? Because when a rhombus has this trick done to it, it becomes a square. So a rhombus is basically a jumbled up square, a parallelogram is a jumbled up rectangle, and that's how you find the areas. It's no different. You just need to remember what's the base and what's the height. Now, the most common misconception people have when they have parallelograms and rhombuses, I don't know, is using the correct measurements to find the area. So I have a parallelogram with a base of 12 and a 7 here and an 8 here, and I have 2 different areas. Now, one of these areas was created from a misconception that's commonly made. The other one's the correct area. Which one's the correct one? Well, the 8 centimetres here, well, is how you got the 96, because you do 12 times 8 to get 96 centimetres squared, and 84 is when you do the 12 times 7. 8 centimetres is not the height of the parallelogram. It's the length of one of its diagonal lines. The actual height is how far it goes from bottom to top, straight, perpendicular, which is 7 centimetres. So the actual area of our parallelogram is 84 centimetres squared, because you're multiplying our base, which is 12, by the actual height, which is 7. So that's it for the first episode of the Complicated Shapes Week. Not really complicated, is it? You just need to make sure you understand which sides of a parallelogram and a rhombus you need to take into account when working out the area. Hence this challenge on the board. I have 2 shapes, A and B. You've got to find out for me which area is the biggest. 2 parallelograms, see how you do. Let's bring on more shapes tomorrow. Good luck. Take care, guys.